Ayan, good afternoon to our teachers around the country at sa ating mga math and science teachers na nakatutok pa rin sa ating Casio Calculators live session this afternoon. So today we'll be having another webinar about projectile motion with the use of ClassWiz calculator from Casio Calculators Philippines. So earlier this morning we have this, it's a Math Tech Day, Casio Technology Session. This afternoon we'll be having a Casio Math and Science Tech Day, and it's all about science ngayong hapon na ito. And we are so lucky to have one of the most distinguished speaker when we talk about science, and later on we will get to know him kung saan siya talaga kung ano talaga yung background niya about this and sa mga talk niya. And without much ado, let us now call on the Casio Educational Unit Head, Mr. Joel Solano, to introduce our speaker. Sir Joel.
Hi, good afternoon. Good afternoon, Sir Buddy. Good afternoon to all our participants for today. Like to welcome everybody for this afternoon session. This session is dedicated to science teachers, general science teachers, no? May nagtanong kasi sa akin bakit bigla tayo nag-shift sa science, no? We are doing this because we receive so many requests na baka pwedeng lagyan ng twist yung aming discussion ng science. So, ito na yung request nyo na magkaroon tayo ng discussion for general science and centered on, I think, more on physics side. So, it is my honor to introduce to you our speaker for today. Magaling na bata to, no? And he is a graduate of BSE Physics from PNU Manila. Well, cum laude lang naman siya. And ongoing ang kanyang master's sa Physics Education and sa UP Diliman. And currently, he's a deputy teacher at Santo Niño National High School. Ladies and gentlemen, I'd like to give the floor now to our speaker, Mr. James Candidia.
Hello, Sir James.
Hello. Hello po.
Ayan.
Hello, sir. Hello po.
Sir James.
Hello, Sir James.
Sir James.
Hello, sir. Hello, Sir Joel.
Hello,
ito
Sir
po, medyo,
kamusta?
medyo kinakabahan at honestly, medyo overwhelmed ako. Pero I'll take the challenge kasi para naman sa atin lahat din ito. So hopefully may maibigay akong output sa ating mga kapwa ko guro sa buong Pilipinas.
Oh yeah. Actually, di lang buong Pilipinas. There are global teachers na nanonood din today. Yun. So the floor is yours now. Take it away, Sir James.
Okay po. So to start, everyone, first, my name is Sir James Candidier. I will be the lecturer for today. Or basically, ako po yung magiging speaker natin, magiging facilitator. So, if ever po na need natin ng questions, feel free po sa ating comment section. So, to start with, siguro punta muna tayo sa menti.com. Okay? Kikita ba?
Sir James, medyo nawala po yung screen.
Wait lang, sir. Okay po. So, punta po tayo dito sa menti.com. Yan. So, kita po ba?
Yes, Sir Joel. Yes, Sir James, kita po.
Ayan, okay. So, first, gusto ko muna pong malaman kung ano po yung background natin, yung mga terms na natatandaan natin sa ating topic for today. So, obviously, as mentioned, ang topic natin is all about projectile motion. So, I have here jumbled words So, ay jumbled letters. So, sa ating mga participants, no, so punta tayo sa www.menti.com and use this code 4107583. And then, what I want you to do is to type a word related to physics based on these jumbled letters. Sige po, bago tayo mag-start. Yan. Okay, thermodynamics. Okay, meron tayong isa. Distance. Okay. So siguro kahit maka 20 tayo, no? Just for me to know if you are participating. So, kinematics. Okay? So siguro baliktad ata yung E at saka I. Okay? So by the way, no, alam ko hapon ngayon. So I will try my best na ma-present yung ating topic such that hindi kayo masyadong maantok. So and unlike sa ating mga previous sessions, medyo solid yung math natin. Ngayon, at the same time, since solid yung math na ginagamit, medyo na-maximize yung ating calculator, yung ating Casio software. So this one, since nasa physics tayo, and ang topic natin is only for limited lang sa trigonometric functions or sa sine cosine, so, at saka arithmetic, so baka konti lang yung ating magamit. So, but then, sa higher physics, may nakita ko mga matrices doon, so feel free to use pa rin or to download the Casio software. So let's check. We have 10 participants. We have these words: kinetic, kinetics, motion, kinematics, distance, and thermodynamics. Sige po. Siguro kahit mga 20 tayo, saka tayo next. So, physics, as we have mentioned before, basically mga teachers naman po ang mga nanonood dito and some students. So, physics is the study of how energy is related to matter. Ang ganun po siya, di ba? So, isa sa mga branch ng physics ay yung mechanics. And under nun, ang ating topic for today. So, kung mapapansin din natin, yung topic natin is compare sa math sessions natin, medyo dugtong-dugtong sila. So, ang topic ko ngayon ay projectile motion. So, more likely, ang dilemma natin ay yung prerequisite topic natin na kinematics, like you have mentioned here. Okay? Sige po. So, actually, yung mga letters na inilagay ko dyan ay jumbled lang. So, it's up to you kung may naaalala tayo, or teachers kung may naaalala tayo, or may na-visualize tayo ng words from the letters na meron tayo ngayon. Okay? Nice. Meron tayong seconds as unit measurement ng time. 15. Ako, medyo konti ang ating participants for today. Shout out pala sa aking mga co-teachers sa Santo Niño National High School. Sana po nanonood kayo dyan. At sa SDO Marikina, School Divisions Office of Marikina. Hello po. Sana po nanonood po tayo. Okay. So hopefully sana ang ating ang discussion natin ngayon ay maging malinaw at maayos kahit na mukhang uulan na, no? Isa sa mga problem natin ngayon as teachers, yung technicalities dahil sa ulan or dahil sa internet, ayun. So sana maging effective pa rin tayo. And hopefully makatulong ako sa pagiging effective natin as physics teachers. By the way, ang topic ko ay projectile motion. Specifically, ang target nito ay, or ang target students or mga topic students na na may encounter ang topic na to ay mga grade 9. Okay? Sige. So last 3 siguro. Okay? So these are the words that we are going to use later on. So most of the words that we are here are related to our topic. Okay? Yan. Last two para makapag-ano tayo. So yan. Sige. Okay? So basahin natin ulit. Kinematics, seconds, kinetics, acceleration, density. Okay? Seconds, heat, thermodynamics, motion, opacity. Okay, nice. Last one. Well, actually, tanggalin ka ba ko, no? Pero medyo overwhelmed talaga ako ngayon kasi alain na ganito yung bigat. Kasi para akong nagto-talk sa thousands of teachers. So, sa ngayon, hindi siya nakakaba kasi nakatapat na ako sa laptop. Pero ako, medyo nakakaba pala to. So, please bear with me. So, naka-21 na tayo. So, 22 and so many and counting. So, para mag-proceed na, para ma-search tayo, let's proceed with our next slide. Okay? I'll give you 15 seconds to answer the question. So, just choose the answer. Ito pa rin yung ating gagawin. Okay? So, let's answer this one for 15 seconds. To. Hannah is jogging with velocity of 2 meters per second. She accelerates at 1 meter per second square for 3 seconds. How fast is Hannah running now? Sige nga. Please enter your answer. Let's see. Okay, 4 meter per second. 100%. 5 meter per second. Okay, may dalawa nang sumagot. So ito ang prerequisite pa na topic dito para masagutan natin. Ito ay kinematics. So paano ba natin ito sasagutan? So how fast is Hannah running now? So basically we are asked to identify or to get know the final velocity of Hannah jogging. So, sorry kasi yung ating, dapat supposedly 2 meter per second siya na small letter lang. Pero dahil hindi ko siya mabago kanina, so please bear with me na lang po. Okay? So, 67% ang sumagot ng 4 meter per second. So, I'll show the answer. So, the correct answer is wait lang. Wait lang. So, wait lang. Ba't wala dito? Wait lang po. So, ang correct answer natin dito, hindi siya nailagay. So, 2 meter per second, siya accelerates. So, 2 plus 1 times 3, answer is 5 meter per second. So, meron siyang initial velocity na 2, then accelerates at 1 meter per second after 3 seconds. So 1 meter per second square times 3 plus 2 meter per second. So, the correct answer is actually 5. Okay? Ano ba? Tama. 1 times 3 is 3 plus 2. So, 5 meter per second. Ako, 4 meter per second. Sige. Next po. Wait lang. Wait. Nawala yung question number 2 ko. Wait lang, naglo-load siya. So, medyo naglo-load siya. Medyo tinry ko na to kanina, medyo naglo-load lang siya. See. Present. Ako, hindi na siya naglo-load. Okay, sige. So, let's try ang ating last question. Anyway, sige, no? I apologize, no, sa ating activity for today. Isang question lang. Pero I prepared for 5 questions sana. So nga lang, naglolo ko yung aking account. Actually, kanina pa to eh. Sige. I will proceed na sa ating pinaka-topic for today. So, all about projectile motion. Okay? So, again, I apologize, no, teachers, siguro yung mga possible dilemma natin na na-encounter natin. So, I apologize here. So, start na tayo sa pinaka-topic natin. So, since nagkaroon ako ng idea kung ano yung background natin sa topic natin about kinematics, let's proceed with our main topic for today. So, our objectives for today ay ito, galing to sa ating curriculum guide. So we are to describe the horizontal and vertical motions of a projectile. Then we are to investigate the relationship between the angle of release and the height and range of the projectile. Then after that, so ito, dinagdag ko na lang, we are to solve problems about projectile motion. Okay? So, I would suggest and encourage everyone to download our Casio software. May link naman na binigay sa atin, no? So, upon using this software, isa sa pinaka maganda or effective na gamitin, especially ngayong pandemic or ngayong ang setup natin is online class. Kasi kung meron tayong calculator, tapos ipapakita natin siya, medyo mahirap siya. At the same time, marami siyang features, no? So, itong gagamitin ko ngayon ay medyo limited lamang sa arithmetic at sa polynomials. Pero if we're going to scan, so marami siya, especially if we are teaching senior high school sa physics, medyo malalim na physics, may mga matrices, pwede natin siyang gamitin. So, what is projectile motion? So, projectile, so yung ating object is any body that is given an initial velocity and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. So, basically, if you are an object and you have an initial velocity and then you have a certain path, meron kang na tinakbo at ang influence lang ng ang motion mo at that point are acceleration or air resistance. So that body or that object is undergoing a projectile motion. So ito, medyo familiar na siguro ang most of the teachers here that we are using simulation just like this one sa ating PhET. So let's say for example, this is our object, ila-launch natin siya at a certain angle. Okay? So once na ni-launch natin siya, okay? So initially meron siyang velocity na 15 meter per second. And then, if you would notice, yung ating path is curved or parabolic. So, at that point, after it was released by our bazooka ba to or canyon, at this point, ang nag-i-influence na lang sa kanyang motion ay ang ating acceleration or ang ating air resistance. Pero normally, sa ating mga problem, okay, nine-neglect natin ang air resistance. Kapag ganito ang setup natin, therefore, our motion is projectile motion. The object is undergoing projectile motion. Okay? So we have two kinds. Ito, hindi ko na masyadong i-highlight yung paggamit ng simulation. Kasi ang focus natin ngayon ay yung paggamit natin ng ating software. But before we proceed, we have two kinds of projectile motion, two types. In fact, meron pang three. Meron pang vertical, meron pa yung projected at an angle, tapos na hindi level. So, ito, discuss lang muna natin yung dalawa. So, first is projected at an angle. So, this one, yung kaninang ginawa natin is one example of projectile motion. So, this motion has two components. Okay? Horizontal and vertical initially, no? So, dito pa lang. Meron na tayong initial na y component and then x component. This is for first type ng ating projectile motion na projected at an angle. Okay? Meron din tayong tinatawag na vertical projectile motion na kung saan ang kanyang angle is 90 degree with respect to our horizontal line. So, I will, siguro tatawagin ko, i-consider ko na lang din siyang projected at an angle. Ang pinagkaiba lang ay sa vertical, ang kanyang range is 0. Okay? So, ang mga examples ko sa ating problem stater ay nasa projected and horizontal projectile. Now, speaking of projectile, horizontal projectile, ang ating initial velocity ay within the horizontal or x component. Okay? Sa ating initial. So, wala tayong upward and wala tayong downward. Okay? And normally, yung ating object is elevated with respect to our horizontal. So, ang ating range here will be at this point to this point. Okay? And if you would notice, compare sa ating projected at an angle, meron tayong flight na pataas and then meron tayong flight na pababa. Okay? Sa horizontal projectile, ang ating motion lang ay pababa. That is the reason why at this point, ang ating motion, meron lang tayong component na positive x and then negative y. Take note na compare, balikan lang natin, no? Compare sa one dimension, ang projectile motion, tulad ng mga nakikita natin, is composed of two dimensions. So, technically, parang nasa plane siya. So, o nasa plane siya, tapos meron tayong x and y. Okay? So, wala tayong z dito, no? So, medyo mas mahirap siya. Okay? Now, like what I have mentioned, we have two projectile motion is two-dimensional motion of an object. And let's say, for example, this one, a boy is about to shoot a ball sa ating ring. You would notice, ito yung ating y, and then ito yung ating x. Now, sir, ano po itong y and x? Necessarily ba dyan tumatakbo yung ating bola? May pupunta dito at may pupunta dito. Dito, ibig sabihin lang nito ay may component siya ng x and may component siya ng y. At kapag pinagsama natin sila, it will create a motion na mag-share silang dalawa. At ang kanyang motion ay towards this one. And we calculate this one through Pythagorean theorem. Okay? Ito lang yung meaning ng ating y and x component. Kung gaano na iimpluwensyahan ni X and Y ang ating ang direction ng ating motion. At the same time, ang kanyang magnitude. So with that, we should know that the horizontal and vertical motion are independent of each other. So meaning to say, regardless kung anong value ng X natin, it doesn't affect our Y. Okay? So, paano naman po sir yung time? Actually, dun lang sila nag-share. So later on, as we go along, mas makikita natin siya. Okay? So, to understand this one further, let's recall muna yung mga parts natin which I already mentioned a while ago. Okay? So, by the way, recall natin yung ating mga equation na ginagamit natin sa ating kinematics equation. We have these equations. So, I will not further elaborate this one na kung paano natin sila nakuha. So, basically, ito, galing siya sa ating v is equals to, or velocity is equals to d over t. Okay? So, nilipat ko lang siya. Ito naman is our average velocity. So, if we have two velocities, probably nag-increase ang velocity niya or nag-decrease, and we want to get the average, ito yun. So basically ito, meron tayong acceleration, and then this one is from our equation sa ating acceleration. Then we manipulate this equation such that we want to identify the final velocity. Okay? On the other hand, ito naman, galing to sa mga equations natin dito. Ito, actually, pinagsanib na lang natin to. So, ginawa natin to so that hindi tayo nakabase sa time. So, if we have the values of initial velocity, the path, and then the acceleration, regardless of the time, pwede natin makuha yung final velocity. And then, ito din, minanipulate din natin using other equations, okay, such that ang makuha natin ay yung ating distance, even if hindi natin alam yung ating final velocity. So, ito, mga topics natin to sa kinematics equation na gagamitin din natin ngayong projectile motion. Okay? So, tingnan muna natin kung alin sa mga kinematics equation ang gagamitin natin for x component. Okay? Remember that sa ating x component, by observation, okay, the velocity or the path of our ball, let's say for example, this one is constant at x component. Yan, constant siya. So, what do you mean by constant, sir? Or horizontal velocity is always constant. Hindi siya nag-accelerate or yung speed niya hindi nagbabago. Kaya from time to time, yung distance between time 1, time 2, hindi siya yung distance ng ating bola hindi nagbabago sa ating x component. At the same time, wala din kasing force, 'di ba? According sa ating law of inertia, a body at rest body in motion will continue in motion at that path. So since walang force na mag-i-stop sa kanya horizontally, therefore, ang ating horizontal velocity is constant. Unless meron tayong air resistance na normally sa ating mga problems, para mas makuha natin yung sagot, nine-neglect natin siya. Okay, with that, since all of these equations are for constant acceleration, and for our x component, the acceleration is equal to 0, ang ating equation lang for x component will be this one. Okay? And then, instead of x, we use the value r. Okay? So, ano ba yung r? So, yung r, yung ating path, horizontal total distance traveled sa ating horizontal. Okay? Later, I did-discuss ko siya sa ating projected at an angle. How about for y component? Okay? So, since sa y component, kung ine-neglect natin yung x natin, imagine natin, you will notice na at a certain height, mag-i-stop siya. Certain height. So, and then, babalik siya pababa. So, meaning to say, may nag-i-influence or may nakaka-apekto sa travel ng ating bola pataas. Okay? At yung naka-influence doon ay ang ating gravity. That's the reason why along y, we are using these equations. Yeah. Yan. But instead of using an unknown value of acceleration, we are going to use the value of g. Okay. And then, since ang ating distance na tinutukoy dito, and then velocity is along y-axis, let us rename them. So, in this case, ating d, instead na d lang siya, we know that it is only for y component. So, we change it as delta y. For our velocity, we change it as along y, for final velocity along y. Same thing with this one, v naught y. Okay? So, notice that yung sign naman natin dito sa ating pangalawang equation, instead ng positive, ginawa ko na siyang negative. Since ang value ng ating g is negative. So, if you would notice, may mga books na positive ang nilalagay nila dito. So, wala namang problema yon. For as long as magiging consistent tayo sa paglalagay ng ating equation. For example, nakuha na natin yung problem, we are to identify the equation we need to use, dapat maging consistent tayo. So, kung may negative na tayo dito, siguro ang lalagay na natin na value ng g ay wala na din negative. Okay? So, it's up to us naman. Ako kasi medyo nasanay ako sa pagkakaroon ng negative sign para lang ma-highlight na nagkaroon ng pagbabago sa ating equation along y component. So, to summarize our ating equations, so these are the equations that we are going to use later on. So, notice, again, sa x component, itong mga equations na to, hindi natin makikita. Kasi, sa x component, like what I have mentioned, ang value ng ating acceleration is 0. So, therefore, ang ating velocity here is constant. Okay? On the other hand, ito naman, since meron tayong influence ng gravity, ang ating acceleration this time is equal to g. And then the values of our values of our velocity and our height or our distance is along y-axis. Okay? Now, we have two kinds, like what we have mentioned, two kinds of projectile motion. The one we mentioned is horizontal projectile. So let's say, for example, this person or this boy is about to kick this red ball horizontally. Okay. So, notice na nasa cliff siya, no? In reality, wala namang nangyayaring ganito, no? Nasa cliff, sinipa mo yung bola. Pero, let's assume for the purpose of discussion, let's assume ganito yung setup natin. Okay? So, since wala tayong space dito, so if you notice, ito ay wala to. Okay? Therefore, yung ating ball ay babagsak dahil sa influence ng gravity. Ngayon, kung ito ay meron dito, babalik tayo sa ating kinematics equation, yung ating one dimension. Since wala to, delete na natin siya. Since wala yan, mag-undergo siya ng horizontal projectile. So, sinipa niya, ganyan ang magiging itsura. Take note na yung ating animation ay, hindi necessarily babagal. Okay? So, for the purpose of lang din siya, discussion. So, normally, ang magiging itsura ng ating bola is babagsak siya ng magpabilis ng pabilis pababa, pero ang galaw niya horizontally is still constant. However, syempre, as it reaches the ground, mag-i-stop na siya dahil tatama na siya dito sa ating floor. Okay. So if we are to draw the path or the trajectory of our fall, ito ang ganyan itsura. Okay. So let's now look for the values of our velocity or our initial velocity. So ano kayang initial velocity dito? Or our range, height, the time it takes or how long yung ating travel, and then yung ating angle. Okay? So ano nga muna yung range? So yung range natin is our horizontal distance. So from the initial point to the end point. So this will be our range. Yan. Okay? So sa ating projected at an angle na type of projectile, meron din tayong range. And kung i-obserba natin, halos kalahati silang dalawa compare sa horizontal. We also have this maximum height. No, that may max yan, no? So the maximum height is from this point, okay, hanggang ma-meet natin yung ating range. That is our maximum height. Okay? Now, what is the value of our velocity? So the value of our velocity is just equal to the value of our velocity along x component. Since like what I've mentioned kanina pa, sa horizontal projectile, ang initial velocity is horizontal lang. So walang values tayo at that point na ni-release siya, wala tayong y component. Magkakaroon pa lang siya siguro after 0.1 seconds na very, very minimal lang. So, siguro dito, at mas lalaki siya ng mas lalaki dahil sa influence ng ating gravity. So, if I am to draw, so here, meron tayong velocity here, velocity vector ng x, may velocity vector tayo ng y dyan. Pero maliit lang. Pero here, may velocity vector tayo ng x, and may velocity vector tayo dito na malaki. Now, yung ating haba ng velocity along x is the same because constant. But sa y, palakas siya ng palakas. Dahil nga sa pataas ng magnitude, dahil nga sa ating gravity. Now, how do we find the values of v, r, and t? So sa v, r, and t muna tayo. So since our velocity is equals to distance over time, at yun sa ating equation kanina, and we know that our velocity is equals to v of x, and the distance traveled along v of x is equals to r, therefore, r is equals to vx. Okay? So, sir, paano siya naging ganito, no? We multiply both sides by time. We cancel time, and then magtatabi na siya dito. So, hindi ko na siya masyadong inilagay. Okay? Sa din to siguro sa magiging dilemma natin, mga teachers, no? Kung paano natin susulat. Honestly, ako, compare sa mga ibang sessions before, wala kasi akong magagamit na pansulat. So, hopefully, maging effective pa rin siya kasi puro animation na lang ginamit ko. So, we multiply both sides by time, we cancel time, so we have r vxt. Yung ating distance now, this time, along x is our range. So, this is how we get the value of our range sa horizontal projectile. Now, how do we get the maximum height? Okay? So, we are going to use this equation. Delta y is equals to v o t or v naught t minus 1/2 gt squared. Okay? Sir, bakit yan po ang gagamitin natin? So, since ang ating Hmax is along y-axis, therefore, we are going to use the equations that we have a while ago, yung nasa y component, given the following. So, ano lang ba ang meron tayo dito? Let's say, for example, meron tayong time, meron tayong final velocity here, and meron tayong initial velocity here. But most of the time, tandaan natin, most of the time, hindi natin nalalaman yung final velocity here. Kasi minsan, yun yung hinahanap sa atin. Pero, all of the problems, regardless kung ano man yan, for as long as it is a horizontal projectile, we know that the value of our y here initially is equals to 0. So, therefore, ito, pwede natin i-neglect or equal na siya sa 0. Okay? And then, ang ating delta y is equals to, is just the same as our height or ating maximum height. Okay? So, this will be our value. Okay? Now, notice yung delta y natin, which is simply along y, the distance along y, is just equals to our h max. Ito yun. Okay? And then, since our v naught is 0, therefore, our equation will be maximum height is equals to 1/2 gt square. Now, sir, bakit po nawala yung negative sign? Remember that this height is measured from top to bottom. And then, ang path din ng ating object is from top to bottom. So, meron tayong negative sign dito technically. So, since may negative dito, tas may negative din dito, magpa-positive siya. Okay? So, remember this equation, the maximum height is equals to 1/2 gt square. So, we can get the value of our maximum height provided na meron tayong time. Yan lang. And ang ating g is just equals to 9.8 meter per second square. Now, how do we get our time? Okay? We can get our time by using also this equation. Okay? Provided that we have the value of our h max, we can simply manipulate this equation. So we multiply both sides by 2 over g, and then square root the answer, then we're going to have our time. Okay? Now let's find the value of our components x, y, then our final velocity. So saan natin ito makikita dito? Yan. So at that point, meron tayong component ng y, meron tayong component ng x. Okay? So mukhang hindi man siya halata, pero may component pa rin siya ng x, kahit na ganyan yung path niya. Okay? Pero, na-neglect na rin siya dahil at this point, dito natin ma-reach yung pinakamataas na value ng ating y. So to do that, since our final velocity along x is just the same as our initial velocity along x, therefore, ito, ililipat lang natin galing dito. Okay? Because along x, constant naman siya. Okay. How about for y? We know that initially, since independence x at saka si y component, i-assume lang natin ang pababa naman. Since ang ating initial velocity here is 0, so we can omit this one. This is equal to 0. And then, use our equation, this one. So, magiging 0 na siya. So, Vfy is equals to negative gt. So, our equation will be Vfy is equals to negative gt. So, we have the values of our x and y here. And notice na magkakaroon, pwede natin makuha ito using our Pythagorean theorem. So, if I am to draw Vfy, parang ganito siya. At this point, ito naman yung ating v of x. Yan. So, ang ating Vf or final velocity is parang ganyan. Yan. Yan. Parang yan ang ating value of Vf. Yan. Ito yung x, ito yung ating y. So, we just used our equation, Pythagorean theorem. Vf is equals to the square root of the sum of square of our final and initial final velocity along x and y. And to get the value of our angle, we use tan -1 or inverse of tan of Vy over Vx. Okay? So these are the equations that we are going to use for horizontal projectile. Now let's try it, or let's use this equation by solving this problem. Okay? So this problem, galing ito sa University Physics. So hindi ko siya gawa. So tingnan natin kung masasagot natin siya. Okay? So let me read. A daring 510 Newton swimmer dives off a cliff with a running horizontal leap as shown in figure 310. Okay? So what must her minimum speed be just as she leaves the top of the cliff so that she will miss the ledge at the bottom, which is 1.75 meters wide and 9.00 meters below the top of the cliff. So yung problem na to, parang medyo tricky siya, no? So parang ang storya niyan, meron tayong diver dito, since magda-dive siya, merong ledge dito, kailangan niyang maiwasan to. So, ano dapat yung ating initial velocity? Okay? So, paano natin siya sasagutan? Okay? So, ang ating initial velocity, para makuha natin siya, along here, is simply Vx is equals to d over t. Kanina. But then, meron tayong dx, or ating range, meron tayong maximum height, pero wala tayong time. Okay? Tingnan natin, label natin ha. Itong range na ledge natin, this is our range. This is our height. So we know to get the value of V naught, okay? Itong V naught, we should have a value of R and we should have a value of T. But in this case, ang value lang meron tayo is R, which is 1.75 meters. So, ang pwede natin gawin, kunin natin yung time. By the way, medyo tricky yung problem natin, no? Kasi, what must her minimum speed? So, ang pwede natin gawin, kailangan dumagpas siya dito sa 1.75. So, pwede natin gawin 1.76, 1.76, or 1.75.001 para at that very point, kung isang point man siya, mamimiss niya. Pero kung at 1.75, technically mamimiss niya pa rin doon. Pero in reality, kung yun ang gagamitin niya, may konting sabit siya, no? Dahil ang kanyang center of gravity ay nasa gitna. So, may mga skin pa siya. So, parang ganun siya titingnan natin. Okay? So, to get the value of our time, okay, we need to use another equation such that we have other values. So, we are going to use this equation. Sir, pwede po ba yung iba? Yes, pwede naman. For as long as dapat ang matira ay time lang. O, like this one. Meron ba tayong maximum height? Yes, meron tayong maximum height na 9. Meron ba tayong G? Meron. This is given. Meron ba tayong time? Which is yun yung hinahanap natin. Okay? So, itong gagamitin nating equation. So, we need to manipulate this one like what I've mentioned kanina para makuha natin yung time. Okay? So, to do that, yan ang ating magiging equation. Okay. May napapansin ba kayo na mali? Ito, feeling ko pwede natin siyang gawin, no? So, if we intend to use an error analysis, pwede natin magpakita ng isang maling equation sa ating mga estudyante. Tapos, we let them analyze if it is correct. So, here, if this is our time, value of our time, technically mali ito, no? Kasi, ang gagawin natin, we multiply this both sides by 2 over G. 2 over G. Yan. No? So, ang mangyayari ay, nasa taas yung 2, nasa baba naman yung G. So, ito, mali ito. Yan. Okay. So, again, pwede natin gawin to, no? Yung intended na mali to check the students' critical thinking, no? So, our equation should be this one. Square root of 2 H max over G. Sir, saan galing po yung square root? So, we need to remove this square sa t. So, therefore, we square root this one. Okay? So 2h max over g. Yan ang ating time o yung travel ng ating person para ma-reach niya yung point na to. Yan. So since meron tayong time, we can substitute that value of time sa ating equation kanina na hinahanap natin yung ating initial velocity. Hindi natin mahanap dahil wala tayong time. Okay? So, to get the time, yan. So, 2h max, so 2 times 9.00 meters over 9.8 meter per second square. So, we cancel this meter. Ay, magiging m square pala to, no? M square, nataas na siya, then square root. Ay, sorry. Makakancel pala yung ating meter, then square root. So, square root ng s is s, tapos yung value ng ano natin, ito. So, sa ating calculator, yan, pwede natin siyang gawin dito. Ito, pwede natin siyang i-present sa ating class ng ganito, no, such that mas makikita nila. So, kasi kung calculator natin, hindi natin siya makikita. And marami tayong pwedeng paggamitan. Kaso nga lang, since ang topic natin is more on use of arithmetic lang, limited tayo. Or hindi natin siya ma-maximize. Pero later on, meron tayong pwedeng gawin, no? Para ma-maximize natin siya. Now, bago pala ako bumalik, press lang natin yung setup natin. So, if you would notice, marami tayong mode or setup na pwedeng gamitin. So, ang gagamitin natin is calculate lang muna. So, equal sign. Natin press yung 1. Yan. Or pwede natin equal sign. Okay? So, we use this one. Check na lang muna natin, ha? So, we use square root and then fraction. So, 2 times 9 over 9.8. Okay? Equals 1.355 seconds. So, this is our value ng time. Okay? So, since meron tayong time, we substitute this one and use our calculator. So, 1.75. Take note, dapat naka-degrees to, no? Over 1.355. Yan. So, our answer will be 1.29 meter per second. So, I also suggest na ito, ano naman natin to, no? Na dapat yung ating equation or ating symbol or unit symbol kasama siya sa ating equation. So, our answer is 1.29. So, the minimum speed of the swimmer should be 1.29 meter per second. So that she will miss the ledge. Actually, mali yata to. Should be the maximum speed of the swimmer. Should be 1.29. Ay, sorry, tama. Minimum. So, minimum speed niya dapat 1.29. Hindi siya lalagpas ng 1.29. Pwede siyang yun. At least value niya is 1.29 meter per second. 1.30 pataas. Ayan. So, let's have another problem. Pero this time, try natin yung projected at an angle. Okay? So, let's say for example, itong same person natin, he is about to kick a ball. Ang kinik niya, ganyan ang naging path. So, in reality, hindi naman ganun kabilis, no? So, magtatakbo siya dito, constant velocity, tapos babagsak. Kasi kanina, parang pabilis siya ng pabilis, no? Tapos, babagal. Hindi ganun siya talaga. So, for the purpose of animation, discussion, at yung path niya, ito yung pakipakita ko muna sa inyo. So, ano yung mga parts na kailangan natin tandaan? So, we have the value of our initial velocity here, okay, which is tangent to our curve. We have our angle here. So, since ang ating type of projectile is projected at an angle, okay, so we can separate this one para mas ma-visualize natin and see that there is X and Y components. Okay, so dapat to pantay to, no? Ayan, dapat pantay. So we have an X component and a Y component for our initial velocity. Ayan. So initial velocity and final initial velocity along Y. So we need to get that later on. Okay, so we also have our maximum height, which is this one, and our range, which is this one. That the distance from the initial point, okay, up to the final point. Okay, so now that we know our labels, let's get or formulate our equation to identify or to get values of v or our initial velocity or velocity, time, range, height, final velocity, and our angle. So recall that at this point, okay, by observation then, okay, since na-reach na niya ang kanyang maximum height, okay, at this point, bababa na siya. Okay, so at this very point, ang pinaka-maximum height niya, ang value ng ating velocity along y is equals to 0. Okay, so may value pa rin tayo ng x na paganyan, pero hindi na siya aakyat. Okay, so ang value ng ating y here is 0. Very crucial siya kasi yan din yung gagamitin natin, idea na yan, para ma-identify natin yung ating mga variables. At the same time, at time traveled, once the object reached this maximum point is half of the total time traveled by our object. So, pag nandito na siya, nakalahati na niya yung kanyang travel, oras na i-travel niya. For as long as hindi na bago yung cases natin sa mga points na to. For example, hindi sinalo, okay? So, ganun pa rin yung time na tinravel dito at the same time dito. So, mahalaga yun, no? Sa maximum height. No, again, sa maximum height, at that point, if this is our object, the initial, the velocity along y is 0, and the time is, the total time, to get the time here, t1 half, or yung half ng time natin dito. Okay? Now, let's first identify the values of this one. Okay, we can also use this sa ating horizontal, pero I prefer to discuss it here sa ating projected at angle. So, we get the values of our Vx by using this function, v cosine theta. Okay? So, for our y, we use sine theta. So, we multiply our value of v, this one, to sine theta. So, technically, ito yung ating angle. Okay? Ang opposite niya ay ito. Ito naman yung adjacent. So, since ang adjacent natin is x and adjacent is cosine, that's the reason why we use Vx is equals to v cosine theta. Now, hindi ko nilagay na yung v naught dito kasi along this every point, ito din yung ating gagamitin equation. On the other hand, sa sine theta natin, sine is opposite. So, the opposite here is this one, which is here. So, dapat parehas lang sila. Okay? Sine theta. Yan. So, to get the value of our v, we simply use the Pythagorean theorem. Once we get these values, we can get the value of this one. If ever, hindi natin alam yung value ng ating velocity. Okay? At ang alam lang natin yung components lang. And normally, nangyayari yan sa mga problems sa mga endpoint. Okay? Okay? But basically, if the air resistance is negligible, yung value natin dito ng V is the same as this one. Okay? Same din sa mga levels natin. Sa magkaka-level sila. Okay? And to get the angle, we're tan dy over dx. Now, this is how we get the velocities. Okay? Along x and along y. Now, how do we get the time? So, remember that ito yung t1 half natin at ang ating final velocity here is 0. If we have our initial velocity value here along y, we can get the time it takes to travel at this point. So, take note na hindi na natin titingnan yung ating range here. Okay? Unless given yung dx natin. Okay? At yung range pwede. Okay? So, since our v final velocity here, ito yun, is 0. Okay? And our v naught along y is v sine theta. This one. Okay? So, no, ito, nasusundan ba natin? So, pfy, this one, ang final velocity here. Yan. Yung ating final velocity. Okay? At ang ating v sine theta is vy, this one. Yan. Yan natin siya inilipat. So, magiging 0 to. So, transpose lang, ilipat lang natin siya para maiwan natin yung time and we will get this equation. Gt is equals to v sine theta. Okay? So, we multiply both sides by 1 over g. To cancel g, we get this value. Okay? But remember, since our final velocity is 0 at this point, meaning to say, yung path, yung time it takes to reach from this point to that point, pataas, ito yun, no? Is simply, ito lang part nito. So, ibig sabihin, 1/2 lang sa maximum height lang. At since ito ay symmetrical, parehas lang naman, we simply add or multiply our value of time to 2. Kaya ito ang magiging ating equation to get the value of our time. T is equals to 2v sine theta over g. Okay? Diyan pa ba kayo? Hopefully, nandyan pa kayo, no? Okay. Next. How do we get the maximum height? So, using our equation like this one, ito, no? Pero this time, we will use an equation such that instead of time, delta y naman yung gagamitin natin, which is this one. Ayan. So, ito yung ating kinematics equation. Let's change this one as our equation here. So, our final velocity, ito, same lang din yan, no? Will be 0. Kasi ang ating titingnan na path dito ay simula dito, okay, papunta dito. Yan. Hirap pag walang, no? Yan. Yan. And then, ang ating initial velocity here is simply our v sine theta. Okay. Yan. So, ito yung magiging v sine theta at ang ating d here, d to the h max. Yan. So, therefore, we're going to have this kind of equation. So, again, no, magiging 0 ito since we're going to reach the maximum height. Okay? And then ang ating path is this one. Ang ating initial velocity here along y is v sine theta, then square, minus 2g h max. Okay? Next. With that, ay, baliktad ata. Dapat nauna to. So, neglect na natin yan. Yan. So, mula dito, na ito na yan. Yan. Lilipat lang natin yung ating minus 2gh max by adding 2gh max on both sides. So, to cancel this one, nag-add tayo ng ganito, no? 2G each, both sides. So, maka-cancel to, mawawala na siyang kasama dito sa V square, V sin theta square. And then, since ang value ng ating V sin theta square is simply V square sin square theta, ito na yung ating magiging final value. Okay? So, para maiwan yung ating H max, we multiply both sides by 1/2 G or 1 over 2G to cancel 2G here. So, yan. So, maka-cancel to. And then, yung 2G natin pupunta dito sa baba. Yan. Yan. Ito. So, to get the value of our maximum height, we use V square sin square theta over 2G. So, for as long as we know the initial velocity and angle, we can get the maximum height if our projectile motion is a kind of projectile projected at an angle. Yan. Next, how do we find our range? So, ating range is this one. Okay? So, to get the range, like we used kanina, range is equals to Vxt. Tama? Tama ba? Range is equals to Vx. O, tama. Vxt. So, ano ba yung time natin? Ang time natin is this one. So, yan, no? Ito, no? Vx is equals to Rt. So, we multiply both sides by t to cancel t here. Iwan yung ating r. Yan. And since yung total time traveled is equal to this value, and our Vx, since it is projected at an angle, is equals to V cosine theta, ipapalitan lang natin itong Vx to V cosine theta. So, magiging ganyan siya. Then, our time, yan, no? Ang ating time here will be this one. Yan. So, papalitan lang natin since ang ating total time traveled is this one. Okay? So, ayusin lang natin siya. We just multiply this one. Makuha natin is R is equals to, or range is equals to V square 2 cosine theta sin theta over G. Okay? Meron tayong trigonometric identity dito, no? Double angle ata. So, 2 cosine theta. So, 2 cosine x sin x, according to this identity, is just equals to sine 2x. So, instead of 2 cosine theta sin theta, we will change this one as sine 2 theta para mas maiksi. Okay? Which is just equal din naman. So, sa math natin, kung babalikan natin, these are just equal. So, ang final equation natin is, sa range is V square sine 2 theta. Take note na ito ay sine 2 theta at hindi siya same sa sine square theta. So, baka malito tayo iba ang ating maximum height, iba din ang ating range. Okay? So, these are the equations that we are going to use to solve problems involving projectile motion in which the projectile is projected at an angle. Okay? Let's have an example. So, let's say, for example, a bullet is fired at an angle of 45 degrees. So, like this one. So, for example, ito yung angle natin. Finire siya. So, since nasa Earth ito finire, hindi siya tatakbo ng straight lang. So, magkakaroon siya ng parang parabolic path. Parang ganyan. Yan. Okay? And the initial speed is 200 meters per second. Okay? So, since we know that if an object is fired at a certain angle, it has two components, the x and the y component. Okay? Ang question natin is, how long is the bullet in the air? So, technically, gaano katagal siya na nasa ere? Okay? And then, the next question is, what is the maximum height reached by the bullet? Then how far does it go in the x direction? So we're just going to use the equations that we have a while ago. Okay? So we need to find the time, the maximum height, and then the range. So these are the equations that we are going to use. Okay? So to get the value of our time, ito, familiar naman tayo kanina, ito diniscuss na natin. Present na natin kung paano natin siya kinuha. So uh, all we need to do is to change our values. So ang value ng V natin, not necessarily as x or y, which is 200 meters per second, sine theta, which is 45 over g. So yan. So try natin siyang i-calculator. Yan. So fraction 2 times 200 sine 45 close parentheses over 9.8. Yan. Sana hindi siya mag-ano, no? Sinunod sa answer natin. So our answer is 28.86. So let's see kung parehas tayong sagot. Yan, 28.89. So 86. So ginawa natin siyang 28.9 seconds. So this is the time traveled, or the time the bullet is suspended in the air. Okay? So kung ititingnan natin siya, matagal ba siya? 28.9. So parang kalahating minuto, no? Kalahating minuto siya naka-suspend sa air. So since magaan naman siya at mabilis ang kanyang pagtakbo at ang kanyang angle is 45 degrees, which by rule, ayan, ito yung layo niya maaabot. So imagine natin siya, parang possible naman na 28.9 seconds, which is also correct din naman to. So, I'm just, tinatry ko lang siyang i-imagine kung possible yung ating sagot. Kasi one way din siya, na pwede natin i-share din natin sa ating mga estudyante kung tama yung ating sagot. Kasi if ever makakuha tayong sagot na 3 seconds, tapos tingin natin tama yung ating process, 3 seconds lang, tapos parang hindi siya imposible, parang imposible siya. So therefore, parang may mali. So ito, mukhang matagal siya. So parang valid naman kasi magaan naman yung bullet. Or siya, not necessarily magaan kasi hindi naman nakaka-apekto yung gaan or yung mass. Aerodynamic, parang ganon. No? So yung air resistant is almost negligible. Okay? So to get the value of H max, the maximum height, use this equation. So let's use our calculator again. So H max is equals to V square. So fraction na lang natin, no? Same as the setup. So ang ating V is 200 square sine. Okay? Balik natin. So lagyan natin siya ng ito. Yan. Kasi sa sine square theta is equals to, parang ano siya, no? Sine theta, tapos naka-square yung lahat. So, 45, sine 45, close parenthesis, para sa 45, and then i-close din natin siya kasi naka-square to yung buong sine 45. Over 2 times 9.8. Sana parehas din sa aking final answer. So, same lang din siya dito. Equals to 1,020. Sige. Yan natin kung parehas, no? Okay, 1,020. Now, itong 1,020, technically 1 kilometer. So, possible, tama naman yung ating sagot. Okay? So, itong nakalagay ko dito, no, pwedeng ito, ang ginawa natin ito, sine 45 then square. Okay? So, sa calculator, medyo mahirap siyang gawin. No? So, instead ito, pero dito, for the purpose of discussion, sine squared 45. Yan. Let's na natin siya dito. Okay? 1020. Now, how do we get the range? Since mayroon pa rin tayong value ng v square at sine 2 theta, sine 2 theta, bilisan ko na, no? Lipat lang natin siya. Let's use our calculator. Okay. So, eto, pwede natin siya, actually, medyo, ano yung calculator natin, yung size niya, no? Pwede nating mapakita yung presentation natin. At the same time, pwede din makita yung calculator, no? Sakto lang siya. Okay? Para makita nyo. So, range natin is, pinaka-input, no? 200 square sine is sine 2 theta. So, we multiply the value of our 40 theta to 45 then close. So, iba siya sa sine square theta over 9.8. Right. Equals 4,081. Okay. So, ito yung maximum height. Ito yung ating range. Let's see kung parehas. 4,081. So, 4 kilometers ang distance, horizontal distance niya. At ang maximum height naman niya is 1,020. So, hopefully, sumabay kayo sa akin sa pagsasagot nito. Okay? Let's try another example. Ito, medyo cute to, no? So, the following figure shows an airplane moving horizontally with a constant velocity of 115 meters per second at an altitude of 1,050 meters. The plane releases a care package that falls to the ground along a curved trajectory. Ignoring air resistance, determine the following. The time required for the package to hit the ground. So, ano lang natin siya, no? Discuss lang natin siya ng bahagya. So, meron tayong plane, tumatakbo siya ng 115 meters per second. So, let us assume, though hindi siya nabanggit dito, that this plane is constantly moving. Hindi siya pabilis. Although, hindi naman siya magiging factor din, kahit na pabilis siya kasi na-release na siya dito. So, technically, hindi na siya nakaka-apekto. So, once na na-release na siya, hindi na mabibigyan ng force ng plane yung ating care package. Therefore, it will continuously moving at 115 meters per second. So, following our first law of motion. So, V naught here is 115 meters per second at this point along X. However, due to the influence of gravity, so the component of Y, the velocity component of Y, is increasing kasi nga pinupull niya pababa. Kaya, in return, magkakaroon tayo ng path na ganito, na curve. Kasi kung hindi siya curve, straight line lang siya, therefore, walang increase ng velocity or walang influence ng acceleration. So, medyo tricky siya, no? Kasi, paano natin makukuha yung time na lalapag yung ating care package papunta dito? Okay? So, do we use or are we going to use our components along X? So, technically, hindi natin siya kailangan. Kasi, una sa lahat, ang tinatanong ay, may hit yung ground. So, para ma-hit mo yung ground, kailangan yung component ng Y ang titingnan natin. Okay, with that, our equation will be this one. Now, why this is our equation? So, we have to use an equation such that ang given lang natin ay, una, initial velocity along Y, which is equals to 0. Okay? And then, the distance, or the moment it is released sa ating plane, distance niya horizontally. Okay? And then the speed. Okay? Though ito hindi na magiging factor. Kasi X component to. So this is our equation, the equation that we're going to use. Actually, sa problem, sa almost mechanic, problem sa mechanics, ang pinaka-tricky na ituro sa bata ay kung anong equation yung gagamitin. Okay? So, pwede natin gawin, i-present natin yung equations, tapos pwede natin i-check kung alin sa mga equation ang may matitirang isa base dun sa ating pangangailangan. So, we need to identify that time. So, alin sa mga equation natin ang may time? Okay. Isa to sa mga may equation natin. Pero dapat lahat ng values na to ay mapunan. Meron ba tayong y? Check. Meron ba tayong v0? Check. Ito by 115? No. Kasi since we're using a long y, so this one is 0. Okay? Meron ba tayong g? Check. May time ba tayo? Ito yung hinahanap natin. So we need to manipulate this equation. So our equation will be according sa ating equation natin sa maximum height. But instead of using it such that ang maiiwan ay maximum height, we need to manipulate our equation. So our equation will be this one. Same lang din sa kanina. So 2h max is equals to 2 t is equals to square root of the quotient of 2 times 150 and 9.8 meter per second square. So let's use our calculator. So square root and then fraction 2 times 1050, okay, over 9.8 meter per second square. Our answer is 14.64 seconds. Okay? So let's say kung kung ganun din yung ating sagot. So 14.6. So that is the time it takes for the package to hit the ground. Okay? So ito din yung ating ito din yung time na na-reach ng ating box papunta din dito. So since pareha sila ng time lang din ang nag-connect sa ating dx at saka dy. Okay? The next question is, how far east the package travels during its fall? So we're going to use our equation, this one. Since we're looking to how far, technically we are asked to identify the range. Okay? How far? Okay? How far east? So to do that, r is equals to vxt. So we just multiply both sides by time to cancel time. This will be our equation. So r vxt, so 115 meters per second. So 115 meters per second times 14.6 seconds equals 1,679. So maka-cancel tong time, and then our answer will be 1,679 meters. So the time required for the package to hit the ground is 14.6 seconds. So it will took 14.6 seconds right after ma-release siya mula sa cargo plane para ma-reach na yung ground. And then, the moment na na-release siya, okay, ang tinakbo niya, horizontally naman is 1,679. Okay? So, I guess this is my last problem. Okay? Ano ba? Yan. A major league hits a baseball so that it leaves the bat at a speed of 30 meters per second at an angle of 36.9 degrees above horizontal. You can ignore air resistance. At what 2 times is the baseball at the height of 10 meters above the point at which it left the bat? So, parang ganito siya, no? So, nag-image sa internet para mas ma-visualize natin. So, our speed is 30 meters per second. The angle of projection with respect to our horizontal or sa point kung saan siya natamaan is 36.9. So, since, ano lang no, for discussion lang, actually hindi to 36, 36, no? Parang more than 45 na lang. Pero please, neglect na lang po. Technically, let's say, nakatilt pa siya ng pababa sa 36.9 with respect to our horizontal. So, we need to identify the time kung saan mamimit niya or marireach ng ating ball yung 10 meters mula sa ating level kung saan siya na-reach. Let's say, for example, ito yung ating level. So, kailangan ma-identify natin yung time na nandito siya. Okay, 10 meters. Kaso nga lang, if we're going to look at it, since symmetrical ang ating path, dapat meron din siya dito sa kabila. That's the reason why we are asked to identify or to look for 2 times or dalawang technically oras, not necessarily hours. So, 2 times. Yan. Ako medyo tricky ito, no? And take note, itong 10 meters above is not necessarily the maximum height. Okay? Hindi siya maximum height. Basta 10 meters lang siya mula dun sa punto kung saan siya tinamaan. Kaso dalawa yun. Paano natin malalaman? Okay? So, ang expected nating sagot, yung isa, mas maliit yung oras, yung isa, mas malaki yung oras. Okay? Kasi, mas maaga siyang na-meet yung point na to, then na-meet din yung point na to. Okay? Yan. So, these are our given values. V is equals to 30 meter per second, and our angle is 36.9 degrees. And our Y is 10 meters. So, we have an initial value of 30 meters per second, an angle, and distance. Alin sa mga equations natin kanina ang gagamitin natin. So, kailangan meron siyang time. Okay? So, hindi pwede yung VF square is equals to V naught square minus 2GD. Hindi siya pwede kasi walang time. So, pwede ba natin gamitin yung delta VF is equals to VA or V naught plus 80? Wala naman yung ating, wala tayong final velocity. Hindi din natin alam kung anong final velocity dito kasi we cannot assume. But obviously, lower than 30 meters per second. Kasi pabagal siya ng pabagal. At dito naman, at same din sila dito, technically. So, paano yun? We will use this equation. Okay? Y is equals to V naught T minus 1/2 GT squared. But instead of using V naught T, we are going to use V sine theta since projected siya at an angle. So, our equation will be like this one. Okay? So, ilipat lang natin such that makikita natin yung ating mga values sa Y, which is 10 meters, V sine theta, then G. At ang time natin na hinahanap natin. So, our equation will be 10 meters, which is our Y, V, 30 meters per second, sine 36.9 T. Ito yung hinahanap natin. Minus 1/2 times 9.8 meter over meter per second square times T square. Okay? So, paano natin siya gagawin? If you are going to look at it, no? Parang siyang ganito, no? Tanggalin natin yung mga values. Okay? At meron siyang certain may parang ano siya, no? May pagkakahawig siya sa ating ax squared plus bx plus c, sa ating polynomial. Ganito, no? Na may second degree. How are we going to get the value of x? Normally, ginagamit natin ay pwede natin gamitin yung quadratic formula. Pwede natin gamitin ang completing the square. Okay? So, since may calculator tayo, thanks na lang sa ating Casio, no? Ito isa sa mga features ng Casio. Ito, very basic pa nga ito kung tutusin. We can use our ClassWiz to get the values of our time. Okay? Hindi na tayo magko-completing the square or hindi na rin tayo ang tawag dito, quadratic formula. So, kasi medyo mas medyo mahirap siya kung mano-mano. So, paano natin siya gagamitin? So, menu, then we are going to look for equation. Yan. So, we can just press equal. So, simultaneous equation or polynomial. So, since hindi naman tayo dalawang equation, and then ang ating is polynomial, we press 2 instead. So, the question is polynomial degree. So, since ito ay ax square, ang value ng ating unknown ay may degree na 2, pinakamataas, we're going to press 2. Yan. So, ito na yung pattern natin. So, we just need to change this setup na magmumukha siyang ganito. Yan. So, 4.9t squared minus 18.0t plus 10. Yan. So, ito yung ating ax squared. Technically, ito yung ating bx, ito yung ating c. So, ililipat lang natin siya dito. So, ano yung coefficient ng ating ax squared or ating 4.9t squared, which is 4.9. Yan. Equal. Yan. So, next naman tayo. Notice that, kung mapapansin nyo, sinasama yung positive. Okay? Kasi, dito din natin i-input yung ating sign, yung positive or negative. So, kung di natin ilalagay yung negative, automatic, ang read ng ating calculator is positive. So, we're going to use negative. Okay? So, negative 18. Yan. 0.0. Copy natin lahat. Equals. And then, ang ating value ng C is 10. Equals. Yan. So, since may value na yung coefficients natin, let's press OK. Equal. So, our first time, or ang ating value ng x sub 1 natin, is 2.99. So, ang value ng t natin dito is 2.99. Yan. Just remember that. Ano yung pangalawang time natin? So, ang pangalawang time natin is 0.6822. Okay? So, we also expect this answer na dalawang magiging sagot kasi sa ating quadratic formula, ano yun, di ba? Square root. Naka-square root siya. So, meron tayong value na positive and negative, plus minus, sa ating b square. So, we are expecting this value. Two answers. So, 2.99 and 0.68. So, our answers are T1, 0.682, and T2, 2.99 seconds. Pinagpalit ko na lang sila kasi yung T1 natin talaga is itong point na to. Ang basa lang ng calculator, inuna niya lang yung isa, yung 2.99. Kasi hindi naman siya, yung calculator naman, since it's about to calculate lang naman the values, regardless kung ano yung setup, uunahin niya kung ano man yung nasa function niya. Pero since ang problem natin at may sinusundan tayong path, ang itiwan natin yung pinakauna. Kasi dito unang ma-reach yung 10 meters, which is ang lower value ng time, which is 0.682. And our T2 is equals to 2.99 seconds. Okay? So, I guess that's all for projectile motion with the use of our Casio software. So, salamat. I hope kahit pa paano may mga na-input ako sa inyo. Okay? Salamat po. Sir? Hello? Hello, sir?
Ayan, hello sir, good evening. Naririnig po ako?
Hindi masyado, sir. Ayan. Hello, sir? Wala akong marinig, sir. Or ako lang ata. Hello? Ay,
So medyo nagka-problem lang, na-mute pala ako kanina. So
okay po.
thank you sir. Thank you Sir James for the discussion about projectile motion, and I hope talagang maraming natuto sa atin about this topic. So at this juncture, let us now call on our Casio Educational Unit Head, Mr. Joel Serrano, for the closing message. Hello Sir
Hi,
Joel.
good afternoon, Sir Buddy ulit and Sir James. Congratulations to Sir James
Thank you,
for
sir.
that very nice presentation, very informative, no? And I hope yung ating mga science teachers may na-pick up sa ating presentation. And I believe very juicy yung presentation, no? Marami talaga silang na-pick up doon. And for me, I myself, actually, I asked my kid na, hindi ka dito manood ka para matutunan mo yung advanced yung physics subject, no? And it's a for me personally, talagang makikita mo na yung connected yung mathematics and science, no?
Yes po.
Dun sa last example mo, nakita ko talaga yung connection. And yung need talaga na for a calculator to be used for physics, kailangan pala talaga dahil ang hirap ng yung ang tataas ng values and same time, kailangan talaga ng calculator, no? And yung hindi lang talaga calculator and kailangan talaga sa ganyang pala klaseng computation yung ang tawag accuracy, no? Yung first example, yung pag tumalon siya ng swimming pool or a cliff yata yon, kung gaano katagal in the same time, gaano kalayo kailangan niyang gawin. So, yan, marami akong tutunan sa part of Casio, no? And I hope sana yung
Thank you,
ating
sir.
mga teachers yung tutunan. Ikaw, Sir Buddy, anong tutunan mo ngayong session?
Ayun nga, so doon yung sinabi mo talaga, no? Kasi meron kasi tayong mga subject na talagang restricted ang paggamit ng calculator because the nature is mathematics. Dito naman sa atin sa projectile motion kasi kailangan natin computein yan. So medyo, nung nag-aaral ako ng high school, ayan isa sa mga medyo nahirapan ako no kasi alam mo naman, hindi naman tayo ganun kaano sa physics. Pero basically, malaking tulong to lalo na sa ating mga learners, and with the help of
Oo.
Sir James, talagang nalinawan
Oo.
yung mga learners natin. Hopefully, it will open opportunities din sa ating mga learners to explore other applications na pwede nila magamit in understanding key concepts in physics and other science-related subjects.
Oo. Marami pa namang physics topics dyan. Marami pa namang
Yeah.
science topics that we can discuss. Na we can combine it
Yes.
with calculators. No? So, ano lang.
Kasi
Yes, sir, buddy.
good thing lang sir, no? Talagang ang topic natin is we are not giving them webinars focusing on a particular chapters,
Mm,
and parang units. We are discussing them per competency
yes.
based in a way na talagang there's a full understanding on how to integrate calculators in the teaching and learning process. So yun po.
Oh, yung milk na tinatawag nga. No? So, it's a wonderful presentation, Sir James. Congratulations.
Thank you, sir.
Maraming salamat. And we're looking forward for another sessions with you now in the near future.
Thank you, sir.
Thank you Sir James, Sir
Yes po.
Joel,
Sir,
and I hope
sir, salamat
Sir
din po
Yes,
sa
Sir James.
James.
opportunity. Actually, di ko na inaasahan yung ganito yung overwhelming na na participants at no. Pero hopefully nakatulong po ako sa mga kapwa ka teachers. Actually po feeling ko may mas magaling at mas may appropriate na presenter sa akin compare sa akin. Pero I hope na kahit papaano nakatulong pa rin po ako. Salamat Sir Joel sa opportunity po.
No problem.
Thank you, Sir James. How about you, Sir Joel? Any last message to our viewers and to our listeners and sa lahat ng science and math teachers sa buong Pilipinas?
Yeah, since nalalapit na yung pasukan this coming October 5. So again, on our side naman, Casio is here to assist the teachers for different kinds of applications, no, especially for online apps. So yung mga emulators, you can visit our education page. It's edu.casio.com. And for yung the availability of our calculators naman, you can visit our official Facebook account. It's Casio Calculators Philippines.com. Yeah, we also have a page wherein makikita nyo yung mga locally made videos namin na ginawa namin for the teachers and by the teachers and for the teachers to sa Pilipinas. So again, maraming salamat and see you again for our next sessions. And maraming salamat DepEd EdTech, Sir Buddy, Sir Marksy, Director Abram, maraming salamat. And Sir James, maraming salamat sa yung pagturo, and to all the participants out there. Thank you very much, and let's keep on learning.
So again, Sir Joel, on behalf of Educational Technology Unit, we would like to extend our sincere thanks for your support to the team and to the Department of Education. Talagang consistent partner ang Casio in delivering quality education. And hindi ito yung nagtatapos, Sir Joel. I hope this will be the start of more webinars focusing on science topics. So, math sa umaga, science sa hapon. So, it's a good combination kasi alam naman natin, math and science ay interrelated sa bawat isa. Again,
nag-iisip na ako, Sir Buddy, kung baka mag-invite din ako sa math teachers. Baka invite ko rin yung mga Casio International teachers. Australia.
Pwede, sir. Pwede.
Tingnan natin kung i-invite natin yung mga busy rin kasing professors din. Yun.
Yeah, with the networks
thank you,
that you have,
Thank you, Sir Buddy.
Yes po. With the networks na meron tayo sa Casio, hindi imposible yan na magkaroon tayo ng mga foreign speakers na magkasalita sa atin, and it's a good opportunity for us to learn doon sa ibang mga sa other teachers around the world, kasi although we are empowered enough on how to use this, iba pa rin kasi yung experience nila na pwede natin ma-apply sa pagtuturo natin sa Pilipinas.
Yes.
So ayun. So again, Sir Joel and Sir James, maraming salamat po.
Salamat. Thank you for having us again. Sir James, congratulations. Thank you, Sir Buddy. Maraming salamat.
Thank you, Sir Joel.
You all teachers, salamat. Bye-bye.
Thank you. And that concludes our webinar session this afternoon, and I hope marami kayo natutunan ng new learnings about the topic na projectile motion, especially yung paggamit ng ating Casio calculators. Again, I would like to apologize kung medyo mahina ang aking audio because we're currently having our DepEd TV taping. So, and hopefully maging maayos ang lahat. October 5 is the start of our new academic year, and sabi ko nga kanina, as a member of the Department of Education, it is our duty to support and to promote the programs and activities of the department. And sabi nga nila, sama-sama, tulong-tulong tayo sa pagsulong ng